Day 2, Problem 1. This has two parts to it. The first part, Part A, gives us an equation, y equals negative 5x plus 2. You may recall this is a linear equation. And we're asked to find its slope. Another word for slope is rate of change. So we're asked to find how is the value of y changing as the value of x changes. And another piece to Part A is to find the y-intercept. If this linear equation was graphed, I notice in Part B we're going to end up doing that down here on the grid, the y-intercept would be a particular dot on that line where it is touching the y-axis. That would be called the y-intercept. So let's tackle Part A. First thing we're asked to do is find the slope. So how is the value of y changing as the value of x changes? There's a few ways to do this, but one thing that could be done is we could figure out what the value of y is as we try different numbers for x. So for example, y equals negative 5. Let's substitute 0 for x and see what the value of y is when x is 0. So here's what the equation would look like if a 0 was put in for x. And figuring out the answer for this, negative 5 times 0 is 0. Add 2 is 2. So the value of y is 2 when x is 0. Now, what if x changes from 0 to, let's say, 1? What if x increases by 1 unit? What will happen to y? So y equals negative 5. And then this time for x, let's substitute in 1. And add 2. Negative 5 times 1 is negative 5. Negative 5 add 2 is negative 3. Now, what slope is getting at is the rate of change. How is the value of y changing as x changed? Well, when x changed by 1 unit, here it was 0, here it was 1, it's increased by 1 unit. What has happened to these values, the values of y? It has changed from a positive 2 to a negative 3. And so the value of y has decreased. It went from positive 2 to negative 3. That means it's getting smaller. And it has decreased by 5 units. That can be represented by negative 5. Now, it's interesting, in the original equation, in the form that this equation is written, I actually notice a negative 5 in the equation. And so this number right here that's being multiplied in front of x is the slope. And we could have just used this number from the very beginning and not gone through these work steps to find out how y has changed. Now, a second part to Part A is to find its y-intercept. Let's do that. Now, the y-intercept of a linear equation is the spot on the y-axis. Maybe it's at positive 6, maybe it's at positive 5, maybe a line is crossing the y-axis at positive 1. It's the spot on the y-axis where the line is going to cross through when it's drawn. And in terms of numbers, any spot on the y-axis will always have as its x-coordinate a 0. Because starting at the origin, when you find dots, if you don't move to the right or to the left at all, then the x-coordinate of the dot is 0. And then for the y-coordinate, you would travel upwards or perhaps downwards to whatever the number is. And so one way to find the y-intercept is to assume that x is 0. And in fact, we've already done that in the first step here. I had put in a 0 for x. I had assumed that x is 0, and I wanted to know what does y equal. And we discovered that y is equal to 2. And so at that point in time, we had already found out that the y-intercept was 2. Now again, it's interesting, in the original equation, there's actually a 2 in the equation right here on the end, the constant number. And so without doing any of this work, we could have used the fact that this was a 2 and had known the y-intercept earlier. And so the slope of the line that would be drawn for this equation is negative 5, which could have been found from this position right here. And the other question we were asked, the y-intercept of that line, is 2. This number here on the end, or when we worked out the math step and the math work and filled in 0 for x, we had worked this out and got an answer of 2, so the y-intercept is 2. Now, using these two pieces of information, we can solve part B of this question, which is graph the equation. Draw a line that this equation has on the grid. The way that that can be done is to make use of these two numbers that we figured out about the line. First, let's use the y-intercept. The y-intercept is a dot on the y-axis. The line is going to cross through this dot. So if we actually put a dot in the right position, we've got a spot where the line is going to cross. And the y-intercept is 2. So let's find 2. Here's 1 and here's 2. There's a dot at 2 on the y-axis. That's the y-intercept. Now the other piece of information we have about this line is the slope, which is -5. That explains how the value of y changes every time the value of x, remember, increases by 1 unit. Okay? So when x increases by 1 unit, the x-axis is moving right, left and right. So when x increases by 1 unit, I'm going to move this 1 unit to the right. There. The value of y, we discovered, is going to decrease because of the negative by 5 units. And we can use that fact to find another dot on the line. So let's do this one more time. When the value of x increased by 1 unit, which takes me to here, the value of y is going to decrease by 5 units. It's going to go down. 1, 2, 3, 4, 5. Here is another dot on the line. And with these two dots, carefully, I can draw a straight line through the dots. And that is a graphical representation of this linear equation. Day 2, problem 2. This question here says, the table shows how much money Ava has saved. Assume the relationship between the two quantities is linear. Find and interpret the rate of change, it's another word for slope, and initial value. That's another way of saying y-intercept. So here's a question that's very closely connected to this question over here, in which we had found slope and y-intercept. Okay? So as I look at this table that contains information, I see that after saving money for 3 months, Ava now has $110 saved. After 4 months of saving money, she has $130. After 5 months of saving money, she has $150. I observe that her money is increasing as time's going by. And one thing we're asked to figure out is the rate of change. At what rate is her money changing as time's going by? Or how fast is her money increasing as time's going by? So let's see if we can figure that out by exploring this chart. The first column of the chart is the variable x. It's how many months she's been saving money. And as we explore changes from row to row, we can figure out our rate of change. So for example, from this row to this row, from 3 to 4 months, we can figure out by how much the value of x has changed. From 3 to 4, it has changed by 1 month. Okay. In that 1 month, if we look at this column of the table, we can figure out by how much the value of y has changed. So in that 1 month, from $110 to $130, the value of y has increased by $20. So her money is increasing by $20 every time the month increases by 1. And that is what rate of change is. How much the value of y changes when the value of x changes by 1 unit. And so rate of change we have discovered that it's increasing by $20 every 1 month. Or another way of writing that is $20 per month. Now the second part to this question asks us to find the initial value, or in terms of vocabulary from the previous question, the y-intercept. But in this story problem, the initial value has an actual meaning in the context of this problem about Ava saving money. So it's asking us, how much money does Ava initially have? That is, how much does she have to begin with? So what is the value of the letter y to begin with? And initially, this would mean that the number of months is 0. That is, before she starts saving money, before any months has gone by, how much money did she have to begin with? Well, the table doesn't begin with x equaling 0 and then count forward 1, 2, 3, 4, and so on. It actually starts giving us some information from the third month onward. But we can certainly work backwards and figure out, well, if she had $110 in the third month, how much money would she have had in the second month? And working backwards from there, how much money would she have had in the first month? And then again, one more time, how much money would she have had in the 0th month? That is when she started. Okay? So if we know that in the third month she has $110, then what about in the second month? So what about when x is 2? Right? So how much money would she have had? Okay. Well, to figure this out, we're going to make use of the fact that we had observed that the rate of change is increasing $20 per month. So if in the third month she had $110, that represents an increase of $20 over the prior month. So 110 subtract $20 means that she had $90 after 2 months of saving. Let's repeat this a few more times. After 1 month of saving, she would have had $90 subtract 20, which is $70. Okay? And one more time. When she started saving, that is initially, she would have had $70 subtract 20, $50. Okay, so her initial value is $50. And then each month she saved $20, and her money gradually increased to $70, and then to $90, and then to $110 and $130, and so on, as we see in the table. But her initial value was $50.